Now going on to the second demonstration. This particular demo pertains to the integrated testing of the SLA negotiation controller. What we're going to show, as already explained, is that granted a set of VMs, we're going to shut down one, for example, imitating the application of an optimization plan, let's say. And then we are going to check how the Dolfin monitoring infrastructure, particularly the SLA one, understands that this action has taken place, and after a while, and right before an SLA violation has been achieved, the policymaker is going to receive a relevant event notification from the SLA negotiation controller. The policymaker is going to change the active policy of the data center, and particularly the optimizer handling all these optimization requests. And then after the relevant notification has been received from the policymaker, the optimizer will also notify the optimizer to schedule a new optimization plan and check how this SLA violation can be treated. So moving on to the Dolfin ECOPDB broker, right here I'm going to sign in. I repeat, this is the IRT testbed that we are talking about. As we can see here, there are 5 VMs on this trial site, and for this particular demonstration, if I click on a UUID, we can see that, for example, this VM4 on server 2 node green is placed under the physical server node called node 4. It has a relatively small flavor, OpenStack flavor, with 1 CPU and 2 gigs of RAM, and we have several logged actions here as part of our testing activities, that is. So regarding the servers, as you can see in that screen, we have 2 servers, namely node 3 and node 4. They are both on the same rack, they are both active, and one of them is green. Now moving on to the logging activity, I'm going to make it up a bit larger. We can see that we have done several actions on top of the VMs and the servers of the testbed. It's 43 actions that have been performed. You can also check the date of the last one here. It's approximately 10 minutes before this demonstration. And I'm going to also have a look at the ECOP optimizer, again at the IRT site. Okay, I successfully signed in. What we can see here is that we have already performed 24 optimization requests. These 24 optimization requests have resulted in the generation of 17 optimization plans. The last one, as you can see, is approximately the same as the actions logged in the ECOPDB. And we have also 24 policies that have been made active since the start of this trial testing. Now going on to the actual demonstration, what I'm going to do now is head on to the driver of the demonstration, select one of these VMs, for example, let's go here, and I'm going to select, let's say that one, VM4 on the server 2 not green. I'm going to select it and hit on suspend so that we can check what happens next. Okay, I'm hitting the demonstration. I have successfully contacted the IRT testbed. Now I'm going to select that one and suspend it. Okay, so you can see that several things happened as I clicked that button. The first one was that the policy actuator here received a new request to hibernate a VM. As you can see, the VM UUID is the one ending in AEC, which is namely that one. No, it has been already shut off. And it has been delegated by the policy actuator to another server, to another service, and the server with this UID has been stopped. Now, as you can see in the last log here, the SLA negotiation controller has been aware of this VM stoppage, and underneath the complex event processing running at the core of the CEP engine of the SLA negotiation controller counts until a certain threshold has passed, so that an availability request, an availability violation notification, and an associated request is issued in the RabbitMQ server, which notifies in turn the policy maker. Now, while I was talking, you can see that the event was already emitted by the SLA negotiation controller. Then the policy maker here received this violation message for the VM with ID, that one, which is exactly the same as the one which stopped and is now active. Then the policymaker contacted, and this can be validated right here, the policy repository component, and then a new active policy was generated and contacted to the optimizer. We're going to also check the newly active made policy in the Dolfin optimizer as well. Then, after a few seconds, a new optimization request was issued and received by the optimizer. And the last part we're going to explain a bit later. So the proof of this communication here is that one. As you can see, the optimizer received a new optimization request. Here we have a printing of the active of the VM that was caught, and the active policy, and we have a log indicating that the new optimization plan with number 18 was generated, which also matches the receipt of the policymaker. Now, if we check at the requests that were made at the policy, at the optimizer, we can see that we have a new request with ID 25, and in response to that we have the optimization plan number 18 being generated. So when I click that, we can see that the various details of the optimization plan. We used the multiple NAS algorithm to solve the problem. We can also have an overview of the active policy. The target was to optimize the SLA and avoid some bias, do not accept cross-DC inbound migrations, etc. We have also one particular constraint dedicated to the SLA violation UUID to let the optimizer understand that this is a VM, an VM SLA breakage policy, and the generated plan indicates that this particular VM should boot. After this optimization plan was generated, the policymaker was contacted so that this plan gets approved or declined, and we can see that proof of this control messages right here. So after this has been approved, it was forwarded back to the policy actuator, and here we can check that the policy actuator received a request to wake up this particular VM, and it was also logged into the ECOP-DB. So if I click on the logging here, we can see that the VM was successfully brought up after approximately 1 minute, which is again the time it takes to the SLA negotiation controller to see that an SLA breakage is about to happen. So going back to the demonstration driver, we can see that all VMs are again active, indicating that everything went well and that the SLA negotiation controller and the relative policies are working as they should.